In this section of 3.1, we're going to finish up the last several questions, starting with number 23, but a little bit of a recap from what we were doing on the first day. With derivatives of polynomials, remember, derivatives, they go down in exponent value, especially when we're talking about the power rule. So with the power rule, you're going to take your exponent, you're going to multiply it to the front, and then you need to subtract 1 from the exponent. Exponents with a base of e, you've got to rewrite it. So it's a rewrite. And then it's always natural log of whatever the base number is. We talked about yesterday how natural log of e is just equal to 1, so we don't have to write it. So again, we rewrite it, and then we write down natural log of the base number. So it's a rewrite. And then the base. With logarithms, you're going to write down 1 over. This is a rewrite. And then what you do is you take the derivative of what's next to natural log. So we're going to apply all these rules and go ahead and finish up our notes from section 3.1. So first of all, these next two questions ask us to find an equation of the line tangent to the function at a given value. Whenever we're talking about an equation of a line, equations of a line, you have to give a line. So we're going to use y minus y1 equals m times x minus x sub 1, where you're going to use the x that they give you. If they don't give you y, you have to plug in your x into the original function of y and then solve for y sub 1. And then you're going to be using the derivative to then plug in your x and figure out what the slope is. You can manipulate point slope form into slope intercept form if you'd like, but you can just leave it like this unless there's a multiple choice question that doesn't give you this form, like I believe number 24 does not. So in number 23, we have to find the equation of line tangent to the function at the given value. So we've got this quartic function, and they only give us that x equals 2. So what we're going to have to do is input the 2 into x and figure out what our original ordered pair is that we're looking for. The instantaneous rate of change at 2 comma something. So with here, we've got 16 plus 24, so now we're at 44 minus 1, 42 plus 1, 43. From here, we can actually figure out then what the slope is. So we're going to take the derivative of y. So you can use correct notation. You can either use y prime or dy over dx. So again, you multiply to the front, 4, and then we subtract 1, x cubed. Multiply to the front, 3 times 3, 9. Subtract 1, x squared. Multiply the 2 to the front, 2 times 1 is 2. X to the first, you don't need the 1 there. Then we've got minus 1. From here, to figure out my slope, we're going to be plugging in your 2 for x. And then we can find our slope. And you should get that the slope is 71. So from here, we've just got y minus y1. My y sub 1 is 43 that we got from right here, and equals m, which is 71, times x minus x sub 2, which is 2. And that's my final answer. This is the equation of the tangent line. For number 24, you're going to do the exact same thing that we did in number 23. So we're going to use the 2, input it to figure out what my y is. And we get that the y value is 25. So from here, we're going to go ahead and figure out what the slope is by finding the derivative of f of x. So we've got f prime of x, and it's again a multiply and then subtract. And then we multiply and subtract, and we're just left with 12x squared minus 3. To figure out my slope, we've got 12 times 2 squared minus 3. So we've got 48 minus 3, which equals 45. So from here, you can pretty much see that your answers are either letter C or potentially letter D, except for letter D has a negative right there, so highly doubtful. There's no way to get that negative there. but we can put it into our equation of a line. So we've got y minus 25 equals your slope times x minus 2. By a little bit of distribution and reverse operation, we get that y equals 45x, and then negative 90 plus 25 is going to be negative 65. So my answer choice is letter C. Now I'm going to pull your attention over here to where it says tangent versus normal. And that's talking about when it wants a tangent line versus a normal line. Whenever it's wanting a tangent line, you're just figuring out the slope as always. I'll say the regular way. And when it's asking for an equation line, a normal line, it's talking about a perpendicular slope. So it's referring to the slope, and they want a perpendicular slope, which means that you're figuring out the opposite reciprocal of whatever the original slope is. And make sure you're using opposite signs and reciprocal, meaning that you're flipping it. Number 25, taking the derivative of the square root of x minus 1 over x cube root x is something. So from here, what we're going to do is I'm going to change this over off to the side. So it's going to be x to the power of 1/2. And you cannot take the derivative unless it's in some sort of exponent. So make sure that you're converting the square root of x into x to the power of 1/2, which I know that if I can quickly multiply this to the front, take the derivative right away, and then I'm going to subtract 2 over 2 instead of minus 1. So we've got negative 1/2. So from here, it looks like we are able to at least eliminate letter D. Now, the next part deals with this section right here. And what we're going to do is I'm going to clean up this denominator a little bit. I know that the x is regularly raised to the power of 1 if nothing's there. And I know that the cube root of x is x to the power of my above number is 1 and my index number is 3. Now, these have the same base, which allows us to add the exponents. So you've got 3 over 3 plus 1 over 3, which equals 4 over 3. Now, again, you can't have a variable in the denominator when we're using the power rule. So we're going to put minus x to the power of negative 4 over 3. Multiply turns positive 4 over 3x, and then you're going to subtract 1. Now, when I subtract 1, I'm going to make it a fraction of 3 over 3, so I can easily combine my numerators, and we get negative 7/3 as my exponent. So it looks like my answer choice is letter B, matches up perfectly. In number 26, it says find the point on the graph of y equals the square root of x between 1, 1, and 9, 3, at which the tangent to the graph has the same slope as the line through 1, 1, and 9, 3. So we're talking about a line. If it's a line, that means it's linear. A line through 1, 1, and 9, 3. All right, and since it's linear, the whole point of me saying that is I could find the slope of the line between 1, 1, and 9, 3. Let's start by at least figuring out the slope of this line. So you've got m equals 3 minus 1 over 9 minus 1, which gives us 2 over 8, or 1/4. Now, if this slope is supposed to be the same as dealing with a line tangent to the graph of y equals the square root of x between 1, 1, and 9, 3, what we could do is we can take the derivative, at least as a start, because I know that when I take the derivative, that's an instantaneous rate of change, aka deals with slopes. So you've got y equals x to the power of 1/2. I can change it so that my derivative is going to be 1/2 x and negative 1/2. And then we could change this even more into 1 over 2 square root x. So the derivative is 1 over 2 square root x. Now, if they're the same, that word same, meaning I can set this equal to this and figure out what the x value is for the point on the graph, at which the tangent to the graph has the same slope as the line through that point. So we're going to set the slope equal to the slope and just solve for x. So you can use cross multiplication and figure out how to make x equivalent. So we get that x equals 4. Now to figure out in my ordered pair, which it should be a dead giveaway right now with the answer choices. So if I want to figure out what the actual ordered pair is, you could take x equals 4 and you could just plug it right back into here. So you get y equals the square root of 4, which equals 2. So you've got 4 comma 2, which lines up perfectly with letter D. And number 27, we've got g of x equals the cube root of x minus 1, and f is the inverse function of g, then f prime of x equals something. So if f is the inverse function of g, in order to find an inverse, as we talked about weeks and weeks ago, we need to switch our x and y's and then solve for the new y. That's how to find an inverse. So I'm going to create x out of g of x, switch the value, the variable, and then we've got y minus 1. So I'm going to cube both sides to start with and just solving, and I get y minus 1, and then we got x plus 1 equals y. Now, back in the directions, it told me that the inverse function is really called f. So I'm going to replace y with f of x. So we've got f of x equals x cubed plus 1. And from here, now we're going to have to take the derivative. So we've got f prime of x equals, this is just power rules. You're going to multiply into the front and then subtract 1. And the answer choice is letter A. Now, we are going to do number 28 on Monday when I'm back as a class. Number 29 and 30, these are both no calculator, and they're both given position, and they're asked to find A and V's. Now, this is the part where you're talking about position, which is S of t, velocity, V of t, and then acceleration, A of t. As you go down and down again, you're taking the derivative every time. So given S of t, find V of 4. First, you're going to have to figure out what the velocity is. So you could say that the velocity is the derivative of position. So we're going to use power rule to figure out what the velocity is. And then we can finally plug in the 4 right here. So we've got 24 minus 4, which equals 20. So our answer is 20. Now, in order to find A of 2, you're going to use your velocity function and find the derivative. So A of t is technically the second derivative of position. When I take the derivative of 6x minus 4, the 6x becomes just 6 and this constant goes away, so you're just left with 6. To find A of 2, well, there's not a t value to plug into, so my answer is just 6. In number 30, they introduced this word, initial velocity of an object. The initial velocity or the initial position or the initial anything is you're finding that position, velocity, or acceleration when the t value is 0. So initial velocity, I'm looking for the velocity when time equals 0. So in order to find initial velocity, we're going to have to take the derivative of position. That is velocity. So we're going to use power rule, 3 times 3, 9, t squared minus 2t plus 4. To find the initial velocity, plug in 0 for t. So you get 0 minus 0 plus 4. So the initial velocity is 4 of whatever units that they wanted to use. To find the value of the acceleration at t equals 2, you're going to find the second derivative of position, which is the first derivative of velocity, and you do not have to necessarily write the v prime of t. But that is how we get to acceleration. So we're going to use our velocity function, power rules. We've got 18t minus 2, and now we've got A of 2 equals 36 minus 2, which is 30 for final answer.